Now let's see single precision representation. So if you are going for single precision, then we know that it is going to use 32 bits, and those 32 bits are distributed like this. 1 bit is given for sine, and 8 bits are given for exponent, and 23 bits are given for mantissa. Since 8 bits are given for exponent, this is going to be excess 128 actually, right? So by 2 power minus 2 power 7 is the least negative number that you can represent if you are going for 2's complement number system. But then instead of going for 128 minus 128, we are going only for 127. I'll tell you the reason. Okay, so because one of the number is not going to be used, so I'll tell you the reason here. Now depending on what the values of this exponent and mantissa are, we are going to we are not going to use some of the combinations. The reason why we don't use some of the combinations is it is very difficult to represent 0 and infinity by going with the regular convention of implicit representation. We have already discussed that, right? So in order to represent 0 and infinity, we need special conventions. So that is why we are using these conventions like this. Now see this. First one is exponent and mantissa. In case if exponent is 0 and mantissa is 0, we are leaving out this combination to represent a value 0, right? And generally plus or minus 0 we write, because in 1's complement we have two representations for 0. Similarly, when you get either plus 0 or minus 0 as a result, when you are doing some computations, and if you have to represent it in floating point number, then for both plus 0 and minus 0, when you get the result, we are going to use the same combination, right? And now one more combination is left out, that is if you give all ones for exponent, then exponent value is going to be 255, and now that combination we are never going to use, right? And whenever m is 0, which means if mantissa is 0 and exponent is all ones, that number is going to represent infinity, plus or minus infinity, okay? And other than 0 and 1, we are going to use 0 to 254. Now the reason why we are using excess 127 instead of excess 128 is, if you are going with excess 128, then there is a chance that we might get 255. The reason is, if a number is having an exponent of 127 let us say, and to that 127 if I add 120, see what I mean to say is, with 8 bits the range possible is minus 128 to 127, right? Now if I add to this 127 a number 128, then it is going to give me 255, right? That is why we are not going with excess 128, we are going with excess 127, okay? So remember that here we don't give 128. Okay, the reason is we are not using 255, the combination 255, and we are not using 255 because we want to represent infinity, otherwise we will not be able to represent it, okay? And now from 1 to 254, we are generally using it as implicit. So whenever our exponent is going to be between 1 to 254, and for some mantissa, whatever mantissa it is, we are going for implicit normalized form, which means in this case the value is going to be equal to minus 1 power s into, what is implicit representation, 1 point m, where m is the mantissa, into 2 power exponent is 127 excess minus 127. So whenever you hit this case, exponent is going to be between 1 to 254, then this is the actual value it is trying to represent. And the next one is, whenever exponent is 0 and whatever the mantissa is, if mantissa is other than 0, then it is representing fractional part. So fractional form means we are not going for any normalization, so it is also called as denormalized form. If you don't use any normalization and if you write the number as it is, then it is called as denormalized form or fractional form. So in this case the value is going to be minus 1 power s into 0.m into 2 power, actually it is e minus 127, but since e is equal to 0, you can directly write it as 127. So this is the form. Are you getting this? So in case if you are going to get any number in this case, then in order to convert it to decimal you have to use this one. If you are getting anything in this case, then in order to convert it to decimal you have to use this one, right? And now E equal to 255 and M is not equal to 0, this combination is not used. It is called as not a number. So it is reserved. It is not a number. Okay. So now how to remember this one is whenever E is 0, right? So whenever E is 0, it is either going to represent your fractional form or 0, which means you can use the same formula for this case as well. Whenever E is 0, you can use the same formula. What happens is here when M is also 0, here you are going to get 0 and the total number is going to be 0, isn't it? See this. If M equal to 0 and E equal to 0, right, you can still use this formula and then you are going to get it as 0. So remember it that way. So whenever E equal to 0, it is going to be either 0 or fractional part, right? And whenever E equal to 255, it is going to be infinity or not a number. Now other than these two, you are going to use the combinations from 1 to 254. Got it? Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkey's ranking is 400. If you are happy to get into IIT Roorkey, then getting into universities better than IIT Roorkey is easier compared to getting into IIT Roorkey. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities or 50 lakh universities, but whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.